Bismillahirrahmanirrahim. Assalamu alaikum. This is the lecture number 6 of physics for class 9th. Chapter number 2, kinematics. That is the second chapter of this book. In this chapter, we will study about a type of mechanics which is called as kinematics. What is kinematics? Kinematics is the branch of mechanics in which we study about the motion of the bodies without reference to force and mass. So in this unit, we will study about all the moving objects without any reference of force and mass. First of all, I will explain you about the rest and motion. Rest. A body is said to be at rest if it does not change its position with respect to its surrounding. For example, as you can see, the golf ball is at rest as it is not changing its position with respect to its surrounding or any observer. Motion. A body is said to be in motion if it changes its position with respect to its surrounding. A running cheetah is an example of a motion. As you can see in the figure, it is continuously changing its position with respect to its surrounding or any observer. Its surrounding can be a building or a tree, and an observer can judge its change of position. The state of rest or motion of a body is relative. For example, a passenger sitting in a moving bus is at rest because he or she is not changing his or her position with respect to the other passengers or objects in the bus, but to an observer outside the bus, the passengers and the objects inside the bus are in motion. As you can see in the figure, all the passengers sitting on their seats are at rest with respect to each other. But if the bus is in motion and some passengers or people are sitting outside or standing outside the bus, according to them, along with the bus, the passengers are also in the state of motion. That is how we can say that rest or motion of the body are relative. Now we will discuss about the types of motion. There are three types of motion. Translatory. The translatory motion have further three types. One is called linear. This is a linear motion. Straight or lengthwise movement. Random, irregular or zigzag movement of the particles or the bodies, or motion along a circular path. All are the types of translatory motion. The next is rotatory motion. In the figure, the spinning motion of the body about its axis is known as the rotatory motion. The next one is vibratory motion, which is to and fro motion about the mean position, as this is the fixed point and this pendulum, as you can see, is moving to and fro about its mean position. Now let's discuss the translatory motion in detail. In translational motion, a body moves along a line without any rotation. The line may be straight or curved. Translatory motion can be divided into 1. Linear motion. Straight line motion of a body is known as its linear motion. 2. Circular motion. The motion of an object in a circular path is known as circular motion. 3. Random motion. The disordered or irregular motion of an object is called random motion. In the previous slide, you have seen the examples of all three types of translatory motion. Now, we will discuss again about the examples of the translatory motion. First is an aeroplane. Moving or flying in a straight line is an example of a linear motion or translational motion. Riders moving in a Ferris wheel are also in translational motion. Their motion in a circle without rotation. A car moving along a curved road, that is on motorway or at any roundabout, etc., are circular. As you can see, the stone tied at the end of the string move in a circular path. The next is random motion. Random motion of a gas molecules is also known as Brownian motion. As you can see in the figure, it is the zigzag or irregular motion of the particles. With the help of these examples, I hope you have fully understood about the translatory motion. Now, rotatory motion. The spinning motion of body about its axis is called its rotatory motion. For example, the top is shown in the figure, which spin about its axis, passing through it, and thus it possesses rotatory motion. An axis is the line. Here it has got this axis. The axis is the line around which the body rotates. For example, ceiling fan. In circular motion, the point about which a body goes around is outside the body. In the rotatory motion, the line around which a body moves about is passing through the body itself. As you can see the motion of a top, in this, the axis is lying inside the body itself. So, if I give the example of the difference between the rotatory and the circular motion, the biggest example is the motion of the earth around the sun. It's circular motion and not the spinning motion. However, the motion of the earth about its geographic axis that causes the day and night is rotatory motion. So, in this case, we have got both the example of circular and rotatory. Now, again come to the top. The top is spinning about its axis. However, its particles of the spinning top moves in a circles, and thus individual particle possesses circular motion. The particles are in the state of circular motion, but the top is spinning as it is spinning about its own axis, so its motion is rotatory motion. There is another example. The motion of wheel about its axis is an example of rotatory motion. This is the axis about which this wheel will be rotating. But again, the particles either are the dust or any air particles moving along with this wheel will have a circular motion. Now, vibratory motion. To and fro motion of a body about its mean position is known as vibratory motion. As you can see in the figure, it's a pendulum clock. The pendulum moves back and forth about its mean position. The motion of a pendulum clock repeats from one extreme to the other extreme. Similarly, the to and fro motion of hammer of a ringing electric bell and the motion of string of a sitar are some examples of the vibratory motion. The next topic we are going to discuss is scalars and vectors. First of all, scalars. A physical quantity which can be completely described by its magnitude is called a scalar. The magnitude of a quantity means its numerical value with an appropriate unit, such as 2.5 kg, 40 seconds, 1.8 meters, etc. The examples of scalars are mass, length, time, speed, volume, work, and energy. Now, vectors. Vectors can be described completely by magnitude along with its direction. Means that along with the number and a unit, we need direction. Examples of vectors are velocity, displacement, force, momentum, torque, etc. It would be meaningless to describe vectors without direction. For example, the distance of a place from a reference point is insufficient to locate that place. The direction of that place from reference point is also necessary to locate it. Now I will explain you how a vector can be represented. To differentiate a vector from a scalar quantity, we generally use bold letters to represent vector quantities such as F, A, and D. As you can see, all are bold. Or a bar or arrow over the symbols such as F, A, and D are having bars on them, as you can see. Or F, A, and D are having arrows on them. Now, graphically, a vector can be represented by a line, segment with an arrowhead, as you can see in the figure. The line AB with arrowhead at B represents a vector V. The length of the line gives the magnitude of the vector V on a selected scale, while the direction of the line from A to B gives the direction of the vector V. As you can see the figure, the length of this line from A to B will give you the magnitude, of the vector v, and arrow, direction of arrow will give you the direction of the vector v. So that is how we can represent a vector. In this figure again, we have shown the magnitude and the direction by drawing a single vector. Now I will explain you how to represent a vector, or how we can draw a vector on a piece of paper. For that, I will take an example of a vector force of a magnitude 80 Newton, which is acting north of east. For that, I need to follow some steps. Step number 1 is draw two lines perpendicular to each other. Horizontal line represents east-west and vertical line represents north-south direction. These are two perpendicular lines. Horizontal is representing east-west and vertical is representing north-south. The next step is select a suitable scale to represent the given vector. In this case, we may take a scale which represents 20 Newton by 1 centimeter line. We cannot draw 20 Newton on a piece of paper, so we need to select the suitable scale in which we can show the value in centimeters. So I found it suitable that I took 1 centimeter to be equal to 20 Newton. You can also take 1 centimeter to be 10 Newton, but in that case the length of the line may vary. You can see in the figure, this is step number 2. Step number 3. Draw the line according to the scale in the direction of the vector. In this case, draw a line OA of length 4 centimeter along northeast. As you can see in the step number 3, we have drawn line OA, which is equals to 4 centimeters and representing the magnitude of a force which is 80 Newton, and the direction is northeast, north of east. So OA is representing a vector F having length 4 centimeter and representing the magnitude of 80 Newton. Step number 4, put an arrowhead at the end of the line. In this case, arrowhead is at point A. Thus, the line OA will represent a vector, that is the force of 80 Newton acting towards north of east. Here we have got arrow A, means step number 4 is completed. Now we have drawn a complete vector representing a force of 80 Newton in the direction of north of east. That is how, or by following these steps, we can draw or we can represent a vector or a force on a piece of paper. I hope you understood. Thank you so much, students. That was the end of the lecture number 1 of chapter number 2. I hope you have got the idea of whatever I have taught you. Thank you so much again. Allah Hafiz.